In Lesson 92, you'll be learning about some uniform motion word problems that deal with equal distances. Now, in this lesson, you'll be applying what you've been learning since Lesson 79 on these systems of equations where you have 4 unknown values and 4 equations. Those were getting you prepared for these uniform motion lessons. Now, something to think about first is what uniform motion means, and that just means basically velocity or a rate. And say you were going 30 miles per hour. That's the same thing as riding 30 miles in 1 hour. Your rate would be 30 miles per hour. Now, if you did that for 3 hours, you can multiply that by 3 hours, and your hours units would cancel, and you'd be left with 90 miles. And so that's showing you that distance, you can figure out a distance traveled by multiplying the rate times the time that you traveled. So what I have there written in red, rate times time equals distance. The rate is 30 miles per hour, the time is 3 hours, and the distance is 90 miles. We can think of that in terms of variables. We could say R for rate, T for time, is equal to D for distance. Now, does that remind you of those problems we've been doing on simultaneous equations, where we'd have that system of 4 equations, and we'd have like R1T1 equals R2T2 and things like that? Well, that was getting you ready for these word problems that you're about to do. Look at this word problem. John and Matt walked to church in 2 hours and jogged home in 1 hour. How far from home was church if they jogged 5 miles per hour faster than they walked? So we want to know how far from home was their church. We want to know a distance. We just said right above there that distance equals rate times time. So we're going to have to know a rate and a time. We know the times here. We know that they walked to church in 2 hours and jogged home in 1 hour. So let's just go ahead and start writing down information that we know and some equations that we know, basically. We know that they walked to church in 2 hours, so we can say T for time walked, T sub W is equal to 2, and the time jogged, T subscript J, is equal to 1. And then we know that they jogged 5 miles per hour faster than they walked. So we could say that the rate jogged, that was 5 miles per hour faster, so 5 plus the rate walked. So we have 3 equations there, but we have 4 unknowns. We still need 1 more equation. And the way we figure that one out is to draw a diagram of this problem. Let's just do that above the word problem. This is a really, really important part. This is something you cannot not do on these problems. So I've drawn 2 vertical lines there to represent the home and the church. So we could just say, like, here's home and here's church. So they walked to church, and so that distance would be equal to the rate walked times the time walked. And we could just say that's equal to dW. They jogged back home, and so that's going to be equal to the rate jogged times the time jogged, which is dJ. Now, look at that. Those distances are the same, right? dW is equal to dJ. Or we could just write down here with our other equations, RW, TW equals RJ, TJ. So now we have 4 equations and 4 unknowns. And that last one was a real important one to figure out. And we were able to use a diagram to help us. And this lesson, remember, it was titled Uniform Motion with Equal Distances. And so that's what we set up in that diagram, right? We had equal distances to compare there. The distance from home to church was the same as from church to home. That helped us set up our last equation. So let's figure out how far away home was. So we're going to have a rate times a time. We know our times. Let's solve for one of the rates. RJ is equal to 5 plus RW. So let's just substitute that into the rate times time equation. And so we have RW times a time walked of 2, so we'll just put a 2 in front here. 2RW is equal to RJ, which is 5 plus RW, times TJ, which is just equal to 1. So we have RW is equal to 5 plus RW. We can subtract RW from both sides, and so that would cancel on the right, and we'd end up with RW is equal to 5. So to figure out the distance walked equals distance jogged, so we'll say distance walked equal to 5 times the time walked was 2, and so that would be 10 miles. And we can write our units. It's not super important that we put our units, but it doesn't hurt to put the units. 10 miles was how far they walked. It's also how far they jogged, because those distances were equal. And so that's how far home was from church, was 10 miles. So this diagram, that was a really important part of the problem in helping us set up our system of equations and figure out what our 4 equations were. Uniform motion problems, this is almost always how they will be, is you'll have 4 unknown values, 2 rates and 2 times. And so you've got to use that information to solve the problem. Set up a system of equations that you can use. Let's do one more. This one says that on Monday, Bob drove to work at 45 miles per hour. On Friday, he drove at 55 miles per hour. If the total traveling time for both trips was 10 hours, how far was it to work? So we want to know a distance here, how far it was to work. And we know we're doing problems with equal distances, so let's go ahead and just set our diagram up first here. And we'll draw 2 vertical lines. And for the trip on Monday, he drove to work at 45 miles per hour. So he went this distance, and we'll call that his distance on Monday. It was the same as the distance on Friday, because he just went to work again. So we'll call that D subscript F. And we know that those 2 distances are equal to each other, and we can think of distance equals rate times time. So we'll say RM TM is equal to RF TF. The rate times time on Monday, that's how we'll figure out the distance here, because they've given us some rates and some information about time. So that's why we have to change it to RMTM equals RFTF instead of just DM equals DF. So we have one equation with 4 unknowns there. That means we need 3 more equations. And it says that he drove to work at 45 miles per hour on Monday. So there's our rate for Monday. And then on Friday, he drove at 55 miles per hour. So there's our rate for Friday. We need 1 more equation, and we can go ahead and solve this system. The last sentence there says, if the total traveling time for both trips was 10 hours. So that means the time for the trip on Monday plus the time for the trip on Friday, those totaled up to 10 hours. How far was it to work then? Well, let's go ahead and substitute back into the RMTM equals RFTF, and we'll solve for one of the times. Once we figure out one of the times, we can solve for the distance, because distance equals rate times time. And so let's go ahead and rearrange that bottom equation. I'll just solve it for M. T sub M equals 10 minus T sub F. And we'll substitute back into the top equation. RM is 45 times Tm of 10 minus Tf is equal to RF, which is 55, times TF. So now we have one equation and one unknown. We can solve this for a numerical answer. And so we'll go 45 times 10 is 450, minus 45 TF is equal to 55 TF. Add 45 TF to both sides. and that cancels on the left, and we end up with 450 is equal to 100 T subscript F. So if we divide both sides by 100, TF would just equal 4.5. And so that's our time for TF. Now if we multiply that by the distance, or I'm sorry, by the rate F, the rate on Friday of 55 miles per hour, we'll get the distance. 55 times 4.5. Now we have to multiply by the rate on Friday because we're talking about the time on Friday. We can't multiply by the rate on Monday. We can't say 45 times 4.5 because that goes with the time on Monday. Rate on Friday goes with time on Friday to get distance. And so we just do 55 times 4.5. You could just do that on a calculator. And that would equal 247.5 miles. And so there's our answer, 247.5 miles. Remember on these problems that distance equals rate times time. So when they ask you how far somebody traveled or how long was the distance, and they've given you rates and times, just try to remember that the distance equals the rate times the time. And so you can change distance to a formula of rate times time. It's a really good idea to draw these diagrams like I drew there on the left side, where you show that the distances are equal. Eventually we'll get into some different types of problems where the distances are not the same, but the diagrams, those will be really helpful in solving the problems. Okay, well that's all for lesson 92.